The topic is volumes of solids of revolution, the disk method. So let's read the definition. Definition says, this time the volume is equal integral from c to d of a of y dy. We do this, the integral goes from y equals c to y equals d of a of y dy. We do this if we cut a cross section through a y, in other words, horizontal. And that a of y is equal to pi r squared. So let's do this example to illustrate. So first, we need to find the volume of the solid generated by revolving the region between the parabolas x equal y squared plus 1. So x equal y squared plus 1 and the line y equal x equal 3. So x equal 3, let's do x equal 3 first. Here's a line x equal 3. This is the line x equal 3, and the parabola x equal y squared plus 1 look like it's like x equal y squared shifted to the right 1 unit. So the vertex starts from here, right? But we're only interested about this region, right? From 1 to 3. Alright, now if we take an arbitrary x and then we cut through here, from here to here, and if we cut through, if we get a cross-sectional, so first of all we're rotating around x equal 3 this way. In other words, the graph is gonna look like, the volume or the solid would look like 1's gonna go from 1 to 5. Right? So the cross-sectional will look like this. And this is the radius. So this is a of y, which is right here. So the radius is going to be what? So if you look at from here to here, this is what we mean with x equal y squared plus 1. Right? That's right here. That's just the value of x. Right? But that's not what we need. The radius is all the way here. In other words, we want all of this, which is 3 minus y squared plus 1. So r will be equal to 3 minus y squared plus 1. That's our radius. So radius is equal, if we distribute the negative, 3 minus 1 is 2. So 2 minus y squared. So therefore, a of y, like always, a of y is pi times r squared, which is equal to pi times 2 minus y squared squared. So now we do the volume. Now this time we want the volume to go from here, right? From this c, this is what we mean with c, to this d. So we need to find those numbers. Those y values come from the intersections of y of x equal 3 and our graph. Our graph is, what is it? X equal y squared plus 1. So how do we do that? To find those, we need to do the intersection. So let's do the intersection here. Intersection. How do we do the intersection? We set both x's equal to each other. So y squared plus 1 is going to be equal to x equal 3, which is 3. Now all we need to do, subtract 3 from both sides. So x squared minus 2 is equal to 0, which means x squared is equal to 2, which means x is equal to minus plus square root of 2. So this is minus square root of 2. This is plus square root of 2. So we know the volume is going to go from minus square root of 2 to square root of 2 of pi times r squared, which is 2 minus y squared squared, dy. Otherwise, to make it easy, I can just take the pi outside and then FOIL what's inside. If you FOIL it, you get 4 minus 2 times 2 is 4, 4y squared plus y squared squared is y4 dy. So the volume is equal pi, and then we need to find the antiderivative. 4 is a constant, so it's 4y minus 4. Integral of y squared is y cubed over 3 plus y5 over 5, and I want this between negative square root of 2 and square root of 2. So the volume is equal pi. Now I'm going to plug in the square root of 2, so 4 times square root of 2 minus 4 over 3 square root of 2 cubed plus square root of 2 5 over 5, and then all this minus, and then I plug in negative square root of 2, so 4 times negative square root of 2 minus 4 negative square root of 2 cubed over 3 plus, I don't have space there, negative square root of 2 5 over 5. Now this is just algebra, so I'll let you do that. Use your calculator and you're supposed to get 64 pi square root of 2 over 15. And that's it for this example.